Good morning, students. We are going to discuss about the course CS 8603 Distributed Systems, and the topic we are going to discuss today is Lamport algorithm. It comes under Unit 2. What are the main objectives of this video presentation is we are going to implement an algorithm for distributed mutual exclusion. You can propose so many algorithms. One of the algorithm is Lamport algorithm. So in this class we are going to discuss about Lamport algorithm, its advantages and disadvantages. So the topic is Lamport algorithm. It is a permission based algorithm. It is proposed by Lamport. Hope you remember Lamport implemented the logical clock algorithm. So here also Lamport implements this algorithm, this mutual exclusion algorithm, as an illustration of his synchronization scheme for distributed system. So in this, all the critical section requests are executed in the increasing order of the timestamp. That is, the request which is having the minimum timestamp is served first. That is the logic. To implement this algorithm, we need three types of messages: request, reply and release. So these three messages are needed to implement this algorithm, and we assume that all the communication channels are following FIFO order. So this is Lamport distributed mutual exclusion algorithm. So we have three steps: releasing the critical section, executing the critical section and requesting the critical section. So one by one we are going to discuss. So to enter the critical section, for example, the site SI wants to enter its critical section. What it is doing means it sends a request message to all the other sites with the timestamp. After broadcasting the request message, it places the request in its request queue. So here TSI denotes the timestamp. When the other site SJ receives that request message, it returns a timestamped reply to the site SI. After sending the reply, it also places that request in its request queue. So that's about entering the critical section. The second step is executing the critical section. So for this, we have to satisfy two conditions. For example, if SI is the initiator, it has to satisfy two conditions. The first one is its timestamp should be minimum when compared with all the other reply messages timestamp. Okay, that is, it has received the message with timestamp larger than its timestamp from all the other sites. And one more condition is its request should be at the top of the request queue. After executing the critical section, you can release the critical section. So when the site SI exits the critical section, it removes its request. Immediately it sends a timestamped release message to all the other sites to indicate its job gets over. When the other sites receives the release message from the site SI, they also remove their request from their request queue. So that's about the algorithm. The message complexity of this algorithm is 3 into n-1. That is, it requires n-1 request messages, n-1 reply messages and n-1 release messages. So totally 3 into n-1 messages we need. What are the drawbacks of this algorithm means it is very unreliable approach and the high message complexity. That is, we need 3 into n-1 messages for every critical section invocation. The performance of this algorithm. So here synchronization delay is calculated. It is equal to the maximum message transmission time. That is 3 into n-1 messages per critical section execution. But anyway, you can improve this by omitting the reply message in some situation. such that you can reduce the message complexity to 2 into n minus 1. So with this we are concluding the Lamport algorithm topic. Thank you all.